Welcome to another exciting educational video brought to you by Vision Concepts Academy. So today we'll be looking at IGCSE physics, and the topic for discussion is weight, mass, and gravitational strength, field strength. So by way of listing out the objective, by the end of the lesson you'll be able to tell the difference between mass and weight. Number two, use and recall the weight formula, which is W is equals to mg, where W is weight, m is mass, and g is gravity. Number three, state unit of mass, weight, and gravitational field strength. Number four, explain why your weight changes on different planets while your mass does not. Number five, solve numerical problems involving weight, mass, and gravity. Number six, interpret simple force diagrams involving weight. And finally, answer exam-style questions on gravitational force. So sit tight as we go into this lesson. Promising to be an exciting lesson today. So if you're not yet subscribed, kindly subscribe to our channel, call your friends, share to your friends, and engage us in the comment section. So we dive in. So what is mass? Let us explain it. What is mass? Mass. Now, mass is the amount of matter in an object. Mass is the amount of matter in an object. The amount or quantity of matter in an object. So the symbol for mass is M. Symbol is M. And the unit of measurement, unit is kilogram. Now this unit is SI unit, kilogram. You have other units. This you have 1,000 gram make 1 kilogram, and 1,000 kilogram make 1 ton. So, but the unit we are considering is in kilogram. And mass does not change depending on location. So mass is constant, even if it is on Earth, it's on the other planets, because you are measuring the quantity of matter inside of it. So, example, you have the same mass on Earth, same mass on Earth, same mass in the moon, other planets, what have you? Other planets. So anywhere you are in the universe, mass is the same. But weight, on the other hand, is the force of gravity pulling on mass. So I'll talk about weight now. Weight is the force of gravity pulling on mass. Weight is the force of gravity pulling on mass. Okay, so this weight, the symbol is W. Remember, mass is M. Symbol for weight is W. And the unit of weight, unit is in Newton. Newton. So N is in Newton, right? Newton. Weight is spelled like this, W for mass, for symbol, and the unit of weight is in Newton. Now, the difference between the mass we looked at before and weight now is that weight changes depending on gravitational field strength of the location. So weight changes depending on the gravitational field strength in your location. Okay, so that means the weight on Earth is different from the weight on the moon or other parts of the planet. Now, I mentioned a new concept here, gravitational field strength. So I'm going to explain what this means, gravitational field strength. So gravitational field strength tells you how strong gravity is in a particular area. It tells you how strong. So the symbol is G. Symbol is G. Unit is Newton per kilogram. And on Earth, this gravitational field strength is 9.8 Newton per kilogram. So IGCSE often uses this. Often uses 9.8 Newton per kilogram, right? Okay. And on the moon, the gravitational field strength is 1.6 Newton per kilogram, approximately 1.6, right? So these values actually will influence the weight of an object on these particular areas. So if I want to get the weight of a body on Earth, this value will influence it. If I want to get the weight of a body on the moon, this value will influence it. Okay, so key formula. The relationship between, so let us understand these formulas. The relationship between weight, mass, and gravitational strength is W is equals to M times G, where W is the weight. Remember, weight is measured in, it's in Newton. Don't worry, let's leave that one first. Mass, M is mass. Mass is measured in kilogram, right? And gravitational field strength is measured in Newton per kilogram. Okay, this is gravitational field strength. Gravitational field strength, right? So I've defined all the parameters that connect this formula. The relationship between weight, mass, and gravitational field strength is given by this. This is the relationship. W is equals to mg. Note this for your exams. And in physics generally, this is the relationship that connects weight, mass, and field strength. Gravitational field strength. Okay. So we'll go into step-by-step worked examples. Okay, so on the board we have a person has a mass of 60 kg. Find their weight on Earth. We are giving gravitational field strength as G is equals to 10 Newton per kilogram. So you are given. So the formula that connects everything here is weight is equals to mass times gravitational field strength. And we are given the mass, M is equals to 60 kg. And gravitational field strength is equals to 10 Newton per kg. So what is the weight? What's the weight? This weight is equals to M is 60 times G is 10. So by the time you say 60 times 10, it will give you 600. 600 what? Newton. Okay, now mind you, by way of dimensioning, if weight is equals to, that is, this weight is equals to, it's a Newton, that's the units, by way of analyzing it. If weight is in Newton, right? Then the mass is in kilogram. And what else? Gravitational field strength is in Newton per kg. You see that these are related dimensionally. How do I mean? I will be putting the units in place of the parameter in the formula. So where I see W, I put N, Newton, right? Where I see M, I put kg, times where I see G, I put Newton per kg. Why I'm writing this formula out to show you that this formula is dimensionally correct. Dimensionally correct means that this thing will give me this thing. Wow. Why? So this is Newton, right? And this is kg times, this one means N over kg. So if kg cancels kg, I have Newton here, I have Newton here. So meaning that even this weight that I'm calling, this gravitational field strength I'm calling Newton per kg is still correct. For IGCSE physics, we are using this. I'm sure in other climes, you will see that G is in meter per second, right? Per second square, acceleration gravity. But we are using it like this here, and it's dimensionally correct. Okay, so this is the answer for that particular question. Let's go to another question. Okay, so I have another question on the board. It says a crate has a weight of 350 Newton on X, and G is equals to 10 Newton per kg. G is what? Gravitational field strength. So we should find its mass. Again, formula is W is equals to mg. Mass is what is not known. I can make m the formula. I say m is equals to W over G. I have W already from the question as 350 Newton, and I have G from the question given as 10 Newton per kg. So 0 cancels 0 here. I'll be having mass is equals to 35 kilogram as the answer. Okay, so we're going to be comparing the the weights on Earth and the weights on the moon. We'll compare it. There are different things. Like I said the first time, it's been affected by the gravitational field strength of your area. So the gravitational field strength of the Earth is different from that of the moon. But let's see it from this question. It says a 2 kg stone is taken from Earth to the moon. I remember I told you that the mass is always different everywhere. Sorry, the mass is always the same everywhere, but it's different. The weight is different depending on the gravitational field strength of that location. So the Earth's gravitational field strength is given as 10 Newton per kg, and the moon gravitational field strength is given as 1.6 Newton per kg. Now, we are told to find the weights on the Earth and the moon. So the first thing, write out the formula for weight. Weight is equals to mg. Now, this m is the same thing, but g differs on the Earth and the moon. We're given that the two scenarios. For Earth, g is 10 Newton per kilogram, and for moon, g is 1.6 Newton per kilogram. So I'm going to solve the weight for Earth first. Weight for Earth, we will now come and say W is equals to M is 2, but G for Earth is given as 10 Newton per kilogram. So this one is 200 Newton. So the weight on Earth is 200. Why the weight in moon is given as W is equals to mg, and m is 2 because it's 2 everywhere, 2 kg everywhere. But for G, the moon, we have 1.6. The 1.6 is gravitational field strength for the moon. By the time you compute that, you'll be getting 3.2 Newton. 3.2 Newton. So you see now that the gravitational field strength, this is not 200, this is 20, sorry. This is 20, not 200. 20. So you see that the gravitational field strength, the weight of the body of this stone, 2 kg stone, the weight of 2 kg stone on Earth is 20 Newton, and the weight of 2 kg stone on moon is 3.2 Newton. You see that the stone weighs more in Earth. Why? Because gravitational field strength is larger. It weighs more on Earth because gravitational field strength for the Earth is larger. Okay? So I'm going to be walking you through some IGCSE style questions on this topic that were just treated. So the first one says, why does an astronaut feel lighter but not lose mass on the moon? Okay, now we said before that the mass is the same everywhere. But when it gets to, when an astronaut there are people who travel out of space, who travel into space. So a man that is weighing 80 kg, for instance, on Earth, he now goes to the moon, and as an astronaut, and now becomes lighter and start to float. You see them floating. If you watch all these space movies, you see them floating. So why is it that the man that has the same mass, 80 kg, and goes to the moon, still 80 kg, but he feels that he has lesser weight and he begins to float? Because G is smaller. Answer to this question. Because G, what is G? G is gravitational field strength, is smaller. Smaller where? Smaller in the moon. Smaller in the moon. So weight decreases. Weight decreases. All right? But mass remains the same. But mass remains the same. See? Mass remains the same. So the key factor for this man feeling lighter is because gravitational field strength in the moon is smaller. So this is another IGCSE question. It says, state the difference between mass and weight. I said it in this topic, that mass is the amount. Answer. Mass is the amount of substance in a matter, and it is measured in kilograms, and is measured, this is how to answer the question, and is measured in kilograms. Put a post of them. Now say while a comma. See, this while is comparing the two of them. While weight is the force of gravity acting on the mass. Acting on the mass, and is measured in what? In Newton. In Newton. This is a very valid, very good answer to this kind of question. You define it, give its units, then put a while to compare, because you are comparing and contrasting. You are telling us the flip side. You are telling us, you are giving us the what's it called? The difference. The difference. While weight is the force of gravity acting on the mass and is measured in Newton. Okay, so this is on that IGCSE question. In fact, this particular one is 2019. That's when it came out, 2019, right? So it says a mass of 2.5 kg is on Earth, where gravitational field strength is 9.8 Newton per kilogram. Calculate its weight. This is very simple again. Model answer. Weight is given as mg, right? Where W is equals to weight in Newton, m is equals to mass in kilogram, and g is equals to gravitational field strength. Gravitational field strength. Field strength. And this one is in Newton per kilogram. See all these things I'm doing. Do it this way. Define your formula. Get your formula. Define all the parameters. Then the next thing to do is to put in your figures in the formula. We're going to calculate weight. So weight is equals to m. M is what? 2.5 kg. And field strength, gravitational field strength is 9.8 Newton per kilogram. By the time you do this maths, compute, you'll be getting 24.5. Weight is equals to 24.5 Newton. So this is the answer. This is the answer. So it's very easy, very easy. So the marking scheme here, correct substitution, you get some mark. Correct multiplication, get some mark. Then unit required. Make sure your unit is stated. See, this one is stated here. Okay. Okay, so here is another IGCSE style question. Physics. It says, describe what would happen to the weight and mass of an astronaut traveling from Earth to the moon. This question came out in 2016. Now the model answer, the answer for this question from this topic, you see the man is going from where? From the Earth to the moon. So what will happen to the weight and mass? Now the mass remains the same. As the man travels, you now say as the man travels from Earth to the moon, say the mass in kilogram remains the same while the weight decreases from Earth to moon. It decreases. Why does it decrease? Because the gravitational field strength in the moon is lesser. So the gravitational field strength in the moon is lesser. It's lesser in the moon than on the Earth. So that's a very simple way of answering that question. So we have come to the end of this topic today. Kindly share the video if you've not shared it before. And if you're not subscribed, please subscribe to our channel. Make a comment on our comment section. And I hope this video has been informative for you. I'd like to thank you.